Welcome back. Today, we are looking at what might honestly be the ultimate xenobiology case study ever recorded. We're going to break down the absolutely extraordinary events on Callia 4, where humanity encountered a profound challenge that completely shattered our understanding of communication, intelligence, and even survival. Get ready, because the science we're unpacking today is absolutely fascinating. Okay, let's dive into this. For 2 whole years, researchers desperately tried to communicate with a planetary intelligence on Calliope 4. They used all the standard first contact protocols, right? They beamed prime numbers. They transmitted the Pythagorean theorem. They even sent out basic representations of the hydrogen atom using high-powered radio transmitters. And the result? Absolute deafening silence. The local intelligence ignored them entirely. You see, to an entity that simply doesn't experience the universe as an individual, a single-source radio transmission was nothing more than a brief spark of electromagnetic static in a very noisy sky. And guys, the clock was literally ticking on this one, which makes this entire case study incredibly tense. The human colony ship Vanguard was just 6 months away. On board were 40,000 humans, suspended in cryostasis, fully expecting to land on a temperate, resource-rich world. If the research team couldn't establish some kind of agreement with the planet's native intelligence, the incoming colonizers would land and just start clearing land for agriculture. The planet would immediately interpret this as localized tissue necrosis, basically an infection, and it would deploy massive predatory subspecies to violently purge the human presence. Section 1. The planet-sized mind and the swarm threat. Now, what's really interesting about this slide is the physical makeup of what actually occupies Calliope 4. It's a planet-wide biological network called the Symphony, and it spans everywhere: the subterranean caverns, the forest floors, the shallow oceans. Individually, its nodes are known as strophes. They look a bit like a trilobite, crossed with a marine nudibranch, about 12 centimeters long, and they glow with these rhythmic violet light pulses. A single strophe possesses only about 80,000 neurons. That is less than a fruit fly on Earth. It's essentially a simple reactive biological automaton. But, and here's the crazy part, the researchers observed that when you put 10,000 of them in a trench, they can mysteriously calculate the complex orbital mechanics of a space station through physical electromagnetic feedback loops. Cognitive xenobiologist Dr. Elena Vance is the one who really spearheaded the breakthrough here. She realized the fundamental flaw in everything they had tried. Human researchers were treating the symphony as a collection of individuals that could be spoken to. But the symphony distributes its cognition across trillions of these tiny nodes. Emitting a radio signal at them was, as Dr. Vance brilliantly summarized, like trying to speak to the cells in a brain by yelling at a finger. Section 2. Rethinking how we speak. So if humans were going to survive this, Alina realized she had to completely throw out linear linguistics. Let's compare the two approaches. Human language is linear, it's discrete, and it's symbolic. We use words as symbols, nouns and verbs, built entirely on the idea of distinct subjects and objects. But a hive mind? It has no boundaries between self and other. Instead, the symphony operates on global state and phase-based dynamics. When strophes gather, they use piezoelectric crystals in their shells to synchronize their electromagnetic emissions. It's a lot like the Kuramoto model of coupled oscillators. Think of fireflies flashing in unison to create a massive synchronized global state. They literally don't use words, they synchronize physical states. To really grasp this, we need to understand a core mathematical concept, an attractor. Picture drawing a giant funnel. If you drop a marble anywhere inside that funnel, it's naturally going to roll down and settle right at the bottom. That bottom point, that's the stable attractor. To the symphony, a concept like danger isn't a symbolic word. It's a physical phase transition of the entire planet's electromagnetic field, shifting exactly the way water turns to ice. This led to Alina's ultimate strategic pivot. She realized, and I quote, "We have to learn their math." To say hello, they couldn't just broadcast a symbolic alphabet message. They needed to introduce an artificial node into the symphony's network that could vibrate at a matching frequency and slowly shift those states. To communicate, they had to physically share a synchronized state. Section 3. The first conversation. Taking this wild theory right down to the planet's surface, Elena and her colleague Marcus Chen ventured into a massive tectonic tear known as the Great Rift. Down here, the density of strophes was just immense, and the ambient electromagnetic field was sliding perfectly between 8 and 14 hertz. Their setup was totally ingenious. They deployed a custom-built device called a phase space modulator, or PSM. They drove 3 titanium rods deep into the wet basalt crust. They weren't broadcasting radio waves into the sky anymore. Instead, they injected low-voltage AC currents and specific LED pulses directly into the planet itself. And what were they transmitting? A chaotic Lorentz attractor. It's a set of differential equations that produces a non-repeating but highly structured shape, much like the chaotic but beautiful wings of a butterfly. At first, literally nothing happened. But then, this incredible moment hits. The telemetry showed a sharp, narrow spike hitting exactly 11.3 hertz. The symphony wasn't attacking the device, it was trying to phase lock with it. Thousands of strophes crawled over each other, forming this dense, writhing dome right over the titanium electrodes. Their violet lights began to pulse in perfect unison, mirroring the chaotic butterfly wing pattern of the machine. They were in. They had literally become a node in the planetary mind. Section 4. Drawing the boundary. So the crucial point is, with the Vanguard hurtling closer every second, the pacing of the mission became absolutely frantic. The team had to quickly establish a safe zone for the incoming humans. They had to define themselves as a distinct boundary condition so the symphony wouldn't purge the colony as an infection. Elena programmed a virtual boundary based on autopoiesis, using a mathematical concept known as a Markov blanket. Essentially, she was mathematically drawing a circle in the sand, telling the planetary network, inside this boundary, our states are independent. We will exist in mutual predictability. We won't perturb you, and you won't perturb us. The symphony's initial reaction? Completely violent. The ground literally roared, and the organisms created an electrical short that very nearly melted the PSM generator. Elena forced Marcus to dial the feedback loop to maximum, making their machine fight the planetary intelligence in this furious mathematical wrestling match. And then, suddenly, the resistance flattened. The phase-locking metric stabilized at precisely 0.618, the golden ratio. The dome of strophes retreated exactly 3 meters from each electrode, creating a perfect, silent clearing. The boundary was accepted. Section 5. The Thermodynamic Treaty. Okay, so the team successfully mapped out a 3 square kilometer landing zone. It was a massive win, temporarily securing physical space for the Vanguard. But Elena knew a volatile, cold piece simply wasn't going to be enough. They were a black box to the planet, and the planet was a black box to them. As she ominously put it, a boundary that is not understood is a boundary that will eventually be crossed. Knowing the colonists would inevitably change the soil chemistry or, just make a mistake, Elena made an incredibly dangerous decision. She chose to connect a high-density brain-computer interface directly to the PSM receiver. She was literally going to plug her own mind into the planetary hive to truly understand it. Now, to actually survive this without her human cortex just completely seizing up from the parallel inputs of a trillion minds, she passed the incoming planetary signal through a neural network called a dimensionality reduction autoencoder. This system compressed the raw, million-dimensional planetary signal into something her brain could actually manage: basic color, sound, and spatial orientation. The moment she connected to what she called the sea of no self, Elena immediately lost her singular perspective. There was no more I. She felt the tectonic plates grinding 10 kilometers down. She felt the metabolic warmth of the sun hitting the northern hemisphere. It was breathtaking. But then, she felt the human colony site. Through the planet's senses, the 3 square kilometer treaty zone felt like a dead scar. It was a cold, silent void in a living body. The symphony was constantly, instinctively trying to heal this uncomfortable wound. And this brilliantly illustrates how she solved it. She couldn't send linear words like home or peace to fix this planetary wound. Instead, she focused on pure human emotion, the fragile, desperate, beautiful struggle of humanity just hoping to survive. The interface converted this emotional state into a complex, high-frequency harmonic, and the network felt it. It didn't absorb humanity into the Hive-Mind, but it shifted its phase space. A new attractor appeared in the planet's equations. Elena had forged a treaty written not in ink, but in the unbreakable laws of thermodynamics. Elena awoke from the interface, forever changed, but ultimately successful. The Vanguard would land safely, and humanity would exist as a high-frequency song, perfectly harmonized with a silent living world. It leaves us with a profound thought to take away from this explainer today. As we go about our loud, chaotic, discrete lives, what silent, emergent systems might be operating unnoticed right beneath our feet? How often do we miss the grand symphony of the world simply because we haven't learned its math?
Please like and subscribe.